All right, yesterday we worked through the example problem on page 134 and had gotten to the point where we established that, what's the last thing we did, KP? The acceleration was?
We were getting to the acceleration.
Okay, so we knew the net force and we knew the mass. The mass is 62 kilograms. The net force was?
292.87 newtons.
Downhill. So you're going to ski downhill. So the acceleration of this person would be 292 divided by, or 292.87 divided by, I should have went to a different screen. Oh well, 62. And that gives me 4.723 meters per second. Okay, that was after a long drawn out, about 15 minutes worth of thinking about stuff. Okay, and we're still not done. So the question was, how fast is the skier going to be going after 5 seconds if they started from rest? All right. Well, so now this looks like DI, DF, VI, VF, A, T, and for kicks and giggles, we also threw in F net and M here, which we used to figure out the A, which we now know is 4.723 meters per second squared. Doing the other ones, DI is 0, DF, we could figure out, they didn't ask me to. So I'm going to call it unknown. Find it if you want. VI is 0, said started from rest. VF, that's what they want to know. So now it's okay, is it Mr. Pernicek, Adeline, KP, Katrina, Irving, which equation fits that? Right? Not acceleration, too many, or not Mr. Pernicek, too many unknowns. Not, oops, there's one more. Sorry. T was 5 seconds. So, what I could actually do, I could solve Adeline for VF. And then I could turn around, well, no, that's what they want me to find. Duh. Well, let's do what they want. VF equals VI plus A times T. I believe that is the equation we'd call Adeline. VI is 0. A is 4.723. T is 5 seconds. So this is going to be, VF is going to be, 20 plus another 3.5, 23 point, it's about 24, 23.8-ish. The book rounded to 24. 4.723 times 5 is 23.615 if you're being ridiculously drawn out. Again, significant digits wise, the book said 24. Oh, had the wrong label. That's what was screwing me up. I'm going, the labels aren't working. Meters per second times seconds is meters, so that wouldn't have been velocity. Meters per second squared. Okay, so cancels out, gives me meters per second. Okay, it works. All right, so question number 38 on the next page. You guys are going to help me set it up. Consider the crate on the incline in example problem number 5. Man, we got to go back to that one. Calculate the magnitude of the acceleration after 4 seconds. How fast would the crate be moving? Okay, well. Alright, the angle is 30 degrees. And they said use the information from number 5, so it's a 562 Newton crate resting on the inclined plane at 30 degrees. Find the components of weight. We found out that they are. Okay. Any day. Somebody hit something accidentally. I think I wrote down the wrong thing. I surely did. 487 and the other one's 281. Because the original weight was like 562. The book did this one as an example, and we also worked through it. Alright, so anyway, this is the information we have up to this point. Now, so continuing to build on that. Calculate the magnitude of the acceleration after 4 seconds. How fast will the crate be moving? Okay. Now, they're assuming, because the problem didn't give me any information to the contrary, so we're ignoring friction. Okay? They want to know acceleration. Well, the easiest way I know how to figure out acceleration is F equals m times a. Now, the green one actually isn't there. It gets erased by putting these 2 orange ones, right? They're the components of the green one. Now, the reason I bring that up is this. So this yellow one is the normal force, which is the same in strength as the perpendicular component of the weight, right? So those two things cancel each other out. What is F net? If there is no friction, this. Okay. But, so how am I going to find A? Well, F net, 281, equals M times A. Uh-oh. 2 unknowns? No. What planet are we doing this on? Earth. Pick Earth. Okay. If we're doing this on Earth, and this thing weighs 562, then its mass is roughly 59 or so. 562 divided by 9.8 is 57.346. Oops. Silly Mr. Bernie. That was the mass. Okay, so the acceleration is going to be that into into 281, which is 4.9. Oh, physics books like to mess with you like that. What's 4.9? It's the acceleration, Mr. Pernicek. Yes, it is. It is also, seriously, it's half of the acceleration due to gravity. Sometimes they like to play with the numbers like that. physics teachers and book authors and stuff are weird, right? You don't have to agree that fast. All right, after 4 seconds, how fast will the crate be moving? This is similar to what we just did. VF equals VI plus AT. I believe that's the equation we called Adeline. 4 seconds. Acceleration of 4.9. VI, they didn't tell me one, so I'm going to assume it's 0. What's VF? 4.9 times 4. 16 plus another 3.6 is 19.6. What'd you get?
19.6.
Okay. Question number 39. If the skier in example problem number 6 were on a 31-degree downslope, seriously, instead of 37, downhill slope, what would be the magnitude of the acceleration?
I see.
No, I really want to do it. What does Adeline say? Skip it or do it?
Whatever you want to do.
That was the political answer because, in all honesty, I was going to say, you guys think this is a democracy? We're doing it anyway. See, there's KP smiling more, right? All right. If the skier in example problem 6, 31 instead of 37, what's the magnitude of the acceleration? Okay, let's get the information we need to get. So, 31 degrees, and they drew it this way, so I'll draw it this way. The skier is on the slope, okay, or snowboarder or what have you. They have a certain amount of weight. Would that change by changing the angle of the slope? No. So there's still a 62 kilogram person. So they still have a weight of, how would I get it? To get their weight, I take 62 times 9.8 to arrive at 607.6. Should be the same number we had yesterday. Newtons. Now, I always do it. 607.6 newtons. I always write my number on the wrong side just to make it annoying. And I know that I can break that into its perpendicular and its parallel components. We did that yesterday. Will the numbers be the same as yesterday?
Yes.
No,
No, they won't.
because we changed the angle here. Okay, so we made it so that the perpendicular component will be just a little bit bigger and the parallel will be just a little bit smaller. Now add on, so if I want the orange one, and I know the hypotenuse, and I know the angle is 31, am I going to use sine or cosine or tangent? I want to find out the length of the orange arrow. Sine, cosine, or tangent? No, that's, take your time. I'll have some pause music.
Like how like spin is making.
It does, it is. It's, I hear you. All right, this side I would call the opposite.
Yeah.
This is the hypotenuse. So which one am I going to use? Sine. Sine of, wow. Sine of 31 is equal to the opposite, which is F parallel, divided by 607.6. And I'm going to get a number, so I just got to get it in my calculator right. Sine 31
times 607.6 is 312.94. And if I want the green one, I would use the cosine. Cosine of 31 equals F perpendicular divided by, oops, I did something weird. Okay. Alright, so when I do that one, I get, dang it, I get the wrong answer because the syntax there. Cosine 31, quick, get it done before they start playing again, times 607.6 is 520.814, and it goes on. Actually be 815. Well, I'm only keeping two numbers, so 520 point, really? 82. Nope. Wow, I'm having a day. 81. If I'm keeping that many digits. All right, now, fair enough. I also know that the normal force, gotta make sure that I change colors so I keep it straight. The normal force would be the same as the perpendicular one, right? So this is F perpendicular, but it's also F normal, okay? What else did we know? We knew that mu is equal to, I think it was 0.15. Is that gonna change? No, it's still snow, it's still skis. It doesn't matter what the angle is, okay? Mu stays the same. All right, so mu is defined as FF over Fn, okay? Well, so we're gonna use this to figure out FF. I'm gonna change colors just because. I'm gonna color FF purple, okay? So mu is FF over Fn. Fn is 520.81. So mu is, and mu is 0.15. FF would be 520.81 times 0.1, that's not a 1. 520.81 times 0.15 is, that's why you do it, so you keep the teacher honest, because he makes mistakes, like misspelling capital F. FF is 78.12 if I'm keeping that many significant digits. Okay. Now, that is oriented up the hill. Okay. So from yesterday's discussion, the net force is when you add all of them together. Now, let me do one thing to make my life easier. I'm going to take away the green one because we replaced it with the orange one and the red one. Okay? So our net force is equal to the red one, which is, I'm not going to keep changing colors, but the red one was F perpendicular, plus the orange one, which is F parallel, plus the purple one, which is the force of friction, plus the blue one, which is the normal force. Okay, and if they could have made it more complicated by giving me like air resistance and stuff. Thank goodness they didn't. Okay, but I know based on our discussion that I almost said the wrong one. This one and this one are the same strength, just opposite directions. I wiped out the wrong one and you guys left me. I took out the green one and I wasn't supposed to. I was supposed to take out the red one, right? My logic was sound, my talking was a little suspect. Are we good, or do I need to go over why that is? We took out the gravity and we replaced it by its two components. Okay, I told you my brain's kind of having a hard time braining today. Okay, so these two are gone because they cancel each other out. And I'm left with F net equals F parallel, that's the orange one, 312.94, plus the friction one, the purple, 78.12. Now before I go farther, labels are good. Before I go farther, we gotta fix something, otherwise things gonna take a bad turn here. Direction is important, and I've been ignoring it. If into the hill, the green one is negative, that's how we would normally define it, then the normal one is positive, colored that one blue, right? Same number, just opposite direction, that's why they cancel. And normally in these problems, down slope is considered positive because that's the direction you end up going, okay? So the orange one is positive, the 312, right? And the friction, which is fighting it, so if orange is positive, the friction has to be negative, so this one would be negative 78. Now I can do the problem. 312 minus 78 is a number. Well, that was foolish. Oh well. 312.94 minus 78.12 is a number. 234.82. That makes sense. What color are we calling this one? Net force. Pink, I guess I called it. $234.82. Positive. It's going downhill. Okay. What will be the acceleration is the question. We're almost done. F equals ma, right? What's the mass of this skier? Same as it was yesterday. 62 kilograms. So 62 times that is, oh, my bad. I told you my brain is braining badly today. It's not 62 times that. It's that divided by 62, right? Because F divided by M would equal A. 3.78 meters per second. Yesterday we had a little faster. Because it was a little steeper. We had 4.7. Okay. There's a reason people do not go on ski vacations in Nebraska. The part of the state I'm from, we got some hills that are better than that. Okay. The driveway when I was growing up, if we'd get enough snow, it would have been halfway decent skiing. Okay. It was about a 90-foot drop over a quarter mile of, that's pretty steep hill by Nebraska standards. Anyway, did we get it? Teacher's edition's happy. Yep. No. Okay. We'll set up the problem while you're gone. Be fast. number 40. Stacy, who has a mass of 45 kilograms, starts down a slide that is inclined at an angle of 45 degrees with the horizontal. If the coefficient of kinetic friction between Stacy's shorts and the slide is 0.25, what is her acceleration? Incline plane. Okay, try that again. Inclined plane problems start with, I'm going to try that one more time. Drawing the problem. Right? So, 45-degree angle. Not sure that's much better. Slide in the playground. Stacy is sliding. Stacy has a weight or a mass. Hi.
What's happening?
Look at that.
No, this is yours.
Oh, well, look at that.
That accidentally,
Last
was it
year.
Christian Lutheran that
Yep.
took it? So they brought it back.
Well, that's awesome.
And there's yours. Oh God, are you recording something? I'm
No,
sorry.
no problem.
No, we got
How-
third.
Well, that's good.
Yeah, it was good. We had a little bit of mishaps. Kipton decided to spell nonchalant with L-E-N-T. He spelled nonchalant, which was hilarious. And then
It
his
happens.
4-letter adjective for whatever in the desert was lack of water. I'm like, 4-letter adjective. Arid was the we were laughing so hard.
L-A-C-K.
Yeah. You're
Oh,
gonna love it when you get these boys. There were 2 8th graders on my team, and the rest,
Well.
the other 4 were 7th graders. But it was all boys because they were the ones that scored the highest.
Cool.
And then they're answering a question, and you know Hadley Schoenberg. Okay, big cowboy. Anyway, he answers, and the answer is Stampede, and all of my group goes, "Let's go, Cowboy!" And I was like, "Oh my God, you guys are so embarrassing sometimes."
You
But
gotta have your fun where you can
they
find
were so
it.
fun. And then at one point, Hadley knocked off the one buzzer, and then it was a
A
domino
chain.
effect.
Boom,
They
boom, boom.
all just slowly fell to the ground, and I was like,
See, that's my physics lesson, coefficient of friction.
"There you go."
All right.
Ask them how. Yeah.
So I wasn't able to like help Aslan with math today because I went in there and at first your sub was talking to me like I was a middle schooler because I thought I was a middle schooler.
Okay.
And then another girl came up and started talking to me and she's like, she's not gonna let you, you can't do the test when the sub is here and I don't know. What do they look like? Really? Taller height for middle schooler.
A girl?
Girl, skinny. She had like brown hair, but it was like light brown, I feel like.
Hi.
I don't know who it was.
Said that you can't take her.
No, she came up and started talking to Aslan because the sub was asking me like what we were working on.
Uh-huh.
And Aslan said the test that she did with me
Oh,
on it.
yeah.
And this girl was like, well, she's not gonna let you sit through a test or make the sub sit through a test with you. And I was really confused what was going on. And I just told Aslan that we could reschedule it because the sub was like, yeah, there's no notes in the.
And I forgot to, and that is my bad,
Yeah,
because
that's
even
fine.
after I emailed you. So you're gone all next week?
Yeah.
What do you have anything tomorrow? Could you?
Actually, we have an SEL lesson in.
Yeah, your Fridays.
You
are-
can probably sweet talk your teacher out
Yeah,
of it.
Mrs. Gorman will probably let me go.
Okay, just come down and let me know, and I'll grab. That's
Okay.
completely on me because I
Yeah.
completely forgot to let
It's
you know.
fine.
Thank you for being so responsible and
Yeah.
showing up. I appreciate it. Thank you.
Alright, now, they were kind enough on this problem to make the slide 45 degrees, which makes less calculating on our part. While we had that brief break, I guess we would say, if the person's mass is 45 kilograms, their weight is 441, 45 times 9.8. So sketching this out, we're up to this part. I need to know the component of the weight. Now, just to be a little bit different, I'm going to figure this out a different way. There's no problem with figuring it out with sine and cosine, okay? But since it is a 45, 45, 90 triangle, if you remember with those special triangles, this particular one, the ratio of the sides is 1, 1, square root of 2, right? So we could solve it as a ratio. 1 over the square root of 2 is equal to F parallel, or either one. I'm going to go with F perpendicular over 441. So 441 divided by the square root of 2 is F perpendicular. So square root 2 is 1.414. I should have known that. Into 441 is 311.83. Now, just because, if you're going, yeah, geometry, Mr. Printycheck, right? Let's trig it. All right, sine of 45 would equal to the opposite, which in this case is F parallel actually, divided by the 441. Now, if I remember right, sine of 45 is 0.707. But let's do it the right way. Sine 45 is 0.707 times 441 is 311.83. Same answer, two different ways. Okay? That's not what the question asked, though. The question asked if the coefficient of friction is 0.25, what's her acceleration? We just figured out that Fn is going to be 311.83 because Fn is the same as the perpendicular component, just in the opposite direction. Okay, so 311.83 times 0.25, or in other words, 1/4 of that is 77.96 approximately. Okay, so FF would be uphill. F downhill is that number, right? So the net force is going to be that minus that. The net force is not that number. 311.83 minus 77.96 is 233.87. Newtons. Now, that is the net force. I have a feeling they want the acceleration. What's the acceleration? Well, acceleration is net force divided by mass. Her mass is 45. 5.19. Now, actually at 197 it'd be 5.20 doing the rounding. My apologies. Yet once again. I'm being really human lately. It's okay. Teachers can be human beings. Alright. I'm calling it a day because my brain is saying stop before you get us in any more trouble. Alright. You do have problems to work on. Tomorrow we may work a example problem, but we'll probably also have some work time. I really want to get and because KP is going to be like gone, I want to get the take